So, hello everyone. Welcome to Intellipaat's live workshop on hands-on project of natural language processing and its fundamentals. So, today's workshop will be conducted by Mr. Ankit Tanmay, who is a senior data scientist with 8 years of experience in providing data-driven solutions to complex business problems. So, presently, he is working in Microsoft as a data and applied scientist. So, guys, let's welcome Mr. Ankit Tanmay into the session. Sir, over to you.
Hey, thanks a lot for the intro. Hi, everyone. Great to meet you all on Sunday afternoon. And I hope we all will gather a lot of things, after the end of the session. The intention of this webinar is to introduce NLP to you guys. When I say NLP, I refer to natural language processing, and we will be talking about fundamentals, what is NLP, and, I will also delve into machine learning and a bit of deep learning. And I would like to hear you as I will be taking you all through the course. Let's get started then. So the agenda today is to introduce you to NLP and also the ML techniques with which we do NLP. Then I'm going to introduce you to deep learning. Then I'm also going to talk about a bit of difference between machine learning and deep learning. I'm also going to talk about what is neural network, different types of neural network, and an introduction to NLP with deep learning. So let's get started. At many of the places, I would like to keep it very hands-on. So a brief about NLP and NLP with ML techniques. So NLP, by definition, or as an acronym, stands for Natural Language Processing in Machine Learning World, and it sits at the intersection between AI, machine learning, and computational linguistic. So, computational linguistic is a branch of computer science. Machine learning is also a branch of computer science. AI and machine learning and computer linguistic, they together, overlaps when we talk about NLP. Computer linguistic basically deals with understanding languages that we humans speak and using machines to interpret or parse those languages. NLP focuses on enabling the interaction between humans and machines. And when we deal with NLP or natural language processing in the context of machine learning and artificial intelligence, what we are interested in is we want to understand insights or meaningful patterns from language data or texts or speech, and we want to gather a decision out of it, out of the information that is presented to us in form of data, which is in form of text or in form of speech. So this is the whole paradigm of NLP. Our objective stays same in many of the projects that you have done so far. I hope you might have been introduced to concepts like regression, classification, clustering, etc. Since you all are familiar with classification, regression, clustering, you know how we generate insights from the data. Similarly, when data is present to you not in form of table but in form of a text block. All right, classification, regression, and clustering, guys, are basically machine learning techniques. Machine learning means you okay, all right, another no. Okay, so machine learning is basically how you use machines to learn from a block of information that is generally present in form of a table or in form of a database that has a schema around it. But many times you also need to learn from unstructured data. Text is a type of unstructured data. When you have to learn or extract information, meaningful information from unstructured data, and the data is present in form of text or in form of speech, you leverage NLP for it. So NLP in machine learning involves using these same ML techniques, which is regression, classification, and clustering, to learn from text and speech data. Now, what all places we generally see NLP in use and NLP plus ML in use? Some basic example is when we do, next word prediction. My bad here, there is a typo. So this is again a good use case of NLP. When you do NLP, right, and you do a sentence evaluator, the sentence evaluator will understand the entire context of the slide, and instead of next word prediction, it will automatically predict next word prediction in many of the email editors. Haven't you encountered such predictions while typing in Gmail, when you just type dear and it will automatically suggest you sir or ma'am, or respected sir or ma'am is automatically suggested, or many times at the end of the mail It will automatically suggest you thanks and regards and your name. Yeah, auto correction, and not just auto correction. So basically, I started talking about NLP, and I am telling everybody what is NLP. So in this slide, if you can read this slide, you can understand that NLP stands for natural language processing. And when you have text data and you want to gather insights from text data or do machine learning or prediction from text data, or some kind of inference out of text data, you use NLP or natural language processing. I just started giving the examples of some of the places where we see NLP in action, and one of the use case that I was sharing with the group was next word prediction in many of the email editors. And that's why group started writing, yes, our email editors are intelligent enough. Subrat also suggested that when we write that please find attachment, and we fail to attach any attachment in the mail, the the prompt automatically asks us if we have forgot to attach the attachment, and do we still want to send the mail or not. So these are some of the basic live impromptu examples of machine learning done using NLP. So when you type a mail and you say, hey, please find attach the Word doc or PPT document capturing the presentation or capturing the synopsis of any research work, the editor is intelligent enough to parse through your sentence and to give you a response when you fail to attach the attachment, that, hey, you know what, your attachment is missing. Do you still want to send the email? So this is, a very good use cases of NLP. And to be honest, it's a very important, feature. Many people think, hey, it's just a basic functionality that, hey, you fail to attach your file and just nudge the user. But in many of the consulting engagements, it is a bad experience when you write that, hey, I have attached a file, and you fail to attach that file and you send a mail to your client. Your client generally, feels confused, and often you get a good RCA from your managers around why you were careless, around not attaching the file when you have just written that, hey, please find the attachment. So that nudge is actually very helpful, and this is one very good use case where machines are helping us humans and NLP is powering it. This is what we are going to learn today. I'm going to introduce you to how NLP functions and what all things you can basically do. So the next in use cases is social media sentiment analysis. Social media sentiment analysis is also very common today, and it was used extensively during the time of elections. And many of the parties, political parties, took bad advantage, or just took negative advantage of this functionality by understanding the sentiment of their voting segment and voting cohort, and they customize their speeches according to their needs and interest. So how did they customize? How did they understood what are basically the needs of a given group of people who belong to their constituency? They did it using social media sentiment mining and social media keyword mining. And again, this is powered by NLP. We also have conversational agents in many customer support sections of shopping websites. That also cuts down on a lot of time that we spend in keeping a man to answer or to respond to users query. So the scale at which these shopping websites operate is generally huge, and for that huge scale, and to support the users in that huge scale, it is very important that we have a somehow automated way of responding to their queries in case anybody has any issue or any feedback. So for that also we use NLP to enable customer support. Now, the first chatbot, which was Eliza. So this is powered using chatbot, and the first chatbot, guys, you guys will be amazed. The first chatbot, Eliza, was created in 1966. So this field of making machine talk to human and making machine understand what humans are writing or typing is not new. It's a pretty old field, and a lot of research has been into. But again, it's not super perfect. Recently, we got the power of cloud. We started having powerful computes, GPUs, and a lot of development happened in machine learning and AI field that even fueled the research in this side of of investigation and scientific discovery. So a lot is yet to happen. I'm going to talk about the future scopes to Mahindra and everyone. So please be excited about it. Let's delve into it. What if people are aware of cognitive algorithms and people started teasing algorithms? So this is where ethics in AI comes in. So another field of data science is ethics in AI. Let me diverge from my path and tell you something, because you guys are aspiring data scientists, right? So welcome to our community of data scientists. These are the kind of conversation that I generally have with my data science folks in my organization, Microsoft. So with NLP, we can fix all this. Great. So one of the conversation that I generally have with my folks when we design scale and data science at scale and do prediction at scale, which is going to impact billions of people, we are very careful about ethics in AI. So ethics in AI basically is, say for example, when you are using YouTube, many times, right, the next video which is recommended to you, it is guided by an AI algorithm or any machine learning or deep learning algorithm. Those algorithm understands what video you have watched, and it then recommends other additional videos to you which are of similar kind. Suppose somebody is having us inclination towards violence, and he goes and searches for a YouTube video related to some community violence or whatever kind of violence. YouTube and the way the algorithm is designed will recommend him similar videos which will further reinforce his interest in violence or any specific community related violence. This is a bad reinforcement, and YouTube will never want this to happen. But given that the algorithm is not something which is specific but a generalized solution, it will keep on, reinforcing a trait or a thinking or a mindset in its users, which is arising because of the machine learning and how the machine learning model is trained. So ethics in machine learning or ethics in AI is one such field which basically talks about what can go wrong with machine learning and artificial intelligence with people. And we are, when we develop such models, right, that operates at scale, are very careful about not breaking any such ethic and try to be as politically and as ethically correct as possible. So yeah, child lock is one such example, but you know what? Even child, they have some beliefs. Say, for example, a child has inclination towards video games. So his first video search in YouTube is video games. YouTube will keep on suggesting him videos related to video games, and eventually he will become a gamer down the line. Similarly, if somebody starts, searching for YouTube videos around painting, right? YouTube will keep on suggesting him videos around painting, and a child who is just learning or developing and 5 year or 6 year old will eventually become a painter. I don't know, who knows? So this is how AI algorithms influence you, and trust me, you are continuously influenced by these ML and AI algorithms. We don't know it, but we are all the time modified, influenced, and shaped by it. So as a data scientist, have learned all these tricks and techniques, right? You basically can see the world from a perspective which general people don't have. You also know, hey, you know what, where that algorithm comes in. I'm searching laptop price. Exactly. Perfect. That's a very basic example of affinity based learning. So Google and YouTube, they are partners, so they exchange data and yep. Great. Again, come back to NLP. So we ensure these ethics. Let's again go to NLP, and this is basically a typical machine learning workflow. So for those who are seeing ML first time or hearing ML about ML first time, this is how a ML project is basically designed. So you have a training data and testing data. So first row is for training. What happens is generally you have training data and you have something called feature extractor. So there are many steps in your code that extracts the features from your training data. And those features are basically the columns. Say, for example, if you want to predict how many people are going to give GRE next year, what all features you will take? You will take the count of people who are staying, the count of population. Then you will take how many of those people belong to a particular age group who generally give GRE. Say, for example, 20 to 40. Then you will check for how many people have enough capital or enough money to pursue GRE. right, of that age group. So another feature will be, are they from affluent background or not? Then another feature can be, have they cleared, BTech or cleared a basic graduation before giving GRE or not? Another feature can be, what is the dollar currency rate? So if currencies are very high and dollar to rupee exchange ratio is super high, GRE will become more expensive and maybe a few people drop out of it. Then you will also check, are bank loans easily available to people or not, right? And what is their credit score? So all these, and you will learn from these various features and would try to predict every individual if he can give GRE or not. And this is one very basic use case of classification model. And here we are classifying a person's possibility of giving GRE depending on several features that I just talked about. So similarly, when we have an NLP project, your data is not a table where you have information about every individual and columns capturing the flags like, hey, what is his credit score? Has he studied till bachelor's or any other feature? You need to mine these features from the text. I'm going to tell you how to mine these features, but essentially, you create such features, you create the labels, and post that you implement a machine learning algo. And these machine learning algo can be a classifier model, it can be a regression model, it can be a clustering model. And finally, you make predictions. What is the label? The label is yes or no. So we are interested in predicting if a person will give GRE, and every individual will be labeled yes or no, depending on his credit score, him belonging to a rich family, him, his study background, and all the other, vectors that belong to the feature space. Who defines the business rules? Business. So, as a data scientist, right, you work closely with your program manager or your product manager. So, your product manager, or maybe the director of the business or VP of the business, is going to tell you what all business rules need to be followed. So, a data scientist evaluates his model with the business stakeholder, and the business stakeholder basically tells him if the model is right and they should be going ahead with it or not. Obviously, data scientist has a lot of flexibility and say in this process. NLP is natural language processing, and I already explained it in the first slide. If you are joining fresh, then I would request you to please watch the recordings of the initial part later. Are you So from the text, we are interested in creating features. So how did we create features? So these are the sequence of steps. We clean the text, we normalize the text, we tokenize the text, we remove stop words, we do part of speech tagging if required, we do named entity resolution if required, we do stemming and lemmatization. And all these things together make the text pre-processing step. Okay, fine. I'm jumping and throwing a lot of jargons to you. What exactly are these? We will learn it. Okay. So when I say cleaning the text, so when you have your data and your data is present in form of text, you want to remove all these gibberish, like, organize the text neatly, all of them together in one file, and all these steps belong to text cleaning. Then you need to normalize the text. Normalizing the text means basically extracting vectors or features from the text and converting all the text into same language which can be passed or handled by your NLP algorithm. Then you need to tokenize. Tokenizing the text means basically splitting a single sentence into tokens or keywords. These keywords are basically your text words that you have in your text block. Then stop words. Stop words. What are stop words? Stop words are basically then removing stop words. Stop words are basically those keywords which we use in our language or day-to-day communication, but they don't have any insightful information for the reader or for the computer to learn from. And these are like words like the, in, or, a, and, there, where, here, why. All these are stop words. So removing stop words means cleaning the text for such words. Then part of speech tagging, it basically is needed in some NLP projects. Part of speech basically, uh, in a sentence, we use noun, we use verb, we use pronouns, we use adjectives. All these are parts of speech. And many times, right, in our sentence, we need to tag them. We are only interested in cleaning our data on parts of speech tagging. So in your sentence, on is not needed, upon, on parts of speech tagging. If I am a reader and I want to know what exactly is your intention from the sentence, I will only evaluate three keywords. I will evaluate elaborate, I will evaluate parts of speech, and I will evaluate tagging. By just seeing these three words, elaborate, part of speech, tagging, I can understand that there is an action for me. All the other words are meaningless to me. How can I know what is meaningful? Most of the time in sentences, verbs are very meaningful or nouns are very meaningful. So when you have to do some kind of a text processing, you do part of speech tagging and you pay more attention to verbs and noun in your model that you will develop. And this is how you can clean your text. You can clean your text and only retain nouns and verbs because they capture more information. Or you can do some kind of an experiment and see where exactly the more information in your data lies, which is the text data. I was disconnected, then I had to reconnect. Don't know if I was only one. There are bad spells or bad magic or dark magic. Uh, to me, there is nothing called dark magic or dark sciences or bad magic or black magic. It depends on the use case. Magic spell that allows you to kill somebody, right? Now with court also legalizing, voluntary death. If somebody is on bed and he's suffering living life every day and he voluntarily wants to die, right? So a black magic spell that allows people to kill themselves becomes a good use case, right? For that person who is already bedridden since many years, suffering and doesn't know what to do with his life. And there is no science today that can fix him or repair him. So it all depends on the use case. What is the what is the difference? So like in database of millions, so, like in a database of millions of sentences, is it easy to do tagging? Yes, it depends on how much compute you have. If you have good compute power, you can do uh you can do part of speech tagging easily. What is the difference between? But dude, Rajanpreet, it all depends on the data scientist who is evaluating. Every algorithm has false positives and false negatives. So you need to evaluate how exactly the algorithm performing on your text data. So if your millions of sentences has some very convoluted sentences where it's not easy to identify for an algorithm which is made for generic use case, where exactly the noun is, or many times you're using noun as a verb or whatever. So at that time, it becomes very difficult or complicated. What is the difference between removing stop words and part of speech tagging? So stop words are filler words that we generally use for the sake of, the way the language is designed. We are accustomed to write sentences in a specified format, but we can still, you know, uh, drop certain keywords and still have meaning. Whereas part of speech tagging involves tagging each and every word that is retained or that is given to the algorithm to the to the part of speech it belongs to. Now, when I say part of speech, I basically want you to go back to your English class when we were in second, third, fourth, till class eighth and ninth, and we studied grammar. We studied parts of speech in grammar like noun, pronoun, adjectives, verbs, adverbs. So part of speech tagging involves tagging each and every word in a sentence to either a noun or a pronoun or a verb or an adverb or an adjective. Again, named entity resolution is about, identifying the individual or any human or any entity from the text. And stemming and lemmatization basically uh, means changing all the words to the root form. Say, for example, run, running, runs, ran, changing everything to run. And lemmatization means lemmatization means getting the root form. So run can be in the root form run, or there are many times root forms ignores certain last word from the word. So that is stemming and lemmatization. All these are the text pre-processing step. After that, what you do is you convert your text into vectors. So how do you convert it into vectors? You convert it into vector by using something like TF-IDF vector or something like word cloud, and you are good for your algorithm to learn. Now, before I go ahead with some hands-on work, I would like to, what is the name entity recall? I just explained. So I want to cover what is NLP and what are some of the challenges in NLP and where exactly we stand today in NLP. So NLP is hard because of a lot of ambiguity. So people, when they write text, they are not very conscious that a machine can read it or a machine has to read it. So many times while writing, right, we write in a hurry and it becomes very difficult. Say, for example, vinyl is linked to gel crash blossoms. So it becomes very difficult for for a language or for a computer model to understand in the language that gel crash blossoms is basically an entity. So here I am talking about a violinist who is linked to Jal Crash Blossoms. And since I know from my context that in what context I have typed this, I can easily parse it and consider Jal Crash Blossoms together. But if a model is deployed to parse it and tag it to different parts of speech, it will tag blossoms as a verb, right? Because what blossoms? Plant blossom, sorry, flowers blossoms, right? Crash is also a verb. Jal crash blossoms. It cannot be one single entity, but it can be it can be evaluated separately. So because there is an ambiguity in the way we want to use a sequence of words together, it becomes very difficult for a sentence model to learn. And you need to experiment with, with n-grams, which is basically how many keywords that you need to take together in order to make sense of your text block. So here, if we go and take a gram of three, we can clearly identify that, hey, you know what? Take Jal Krasm blossoms together, and most likely Jal Krasm blossoms looks like an entity rather than individual, meaning which they have, like crashing and blossoming. It belongs to a group Jal Grass blossoms, and I'm talking about the violinist, which is linked to it. So this is how I want to, I want to explain the ambiguity which generally lies in an NLP project, and this makes NLP hard. So a lot of discretion of the data scientist working on the project is used in order to evaluate or understand, such solutions or such understanding or learning by the ML model. Then I have teacher strikes idle kids. Also, say for example, vinyl is linked. Instead of L, I use inked because many times when we type or when we write sentences, we are very careless. Red tape holds up new bridges. Hospitals are sued by 7 foot doctor. So you see seven here, it becomes ambiguous. You need to convert it and you need to again, parse it properly. Juvenile code to try shooting defendant. Again, there exists ambiguity which needs to be consciously evaluated and learned from. Now, where do we stand today? So, in terms of language technology today, we have mostly solved problems around spam detection, part of speech tagging, named entity recognition. So, named entity recognition basically is identifying the entity involved. What all entities are generally there? We have person, place, and company. Say, for example, Satya met with LinkedIn in Palo Alto. So, named entity recognition will clearly separate out Satya, Palo Alto, LinkedIn. And this has been mostly solved. So from sentences, it is now very, we have models that have very good accuracy at identifying the named entity from a sentence. We have also solved the problem of part of speech tagging to a great extent. Part of speech tagging involves, dividing the sentence into adjectives, nouns, adverbs, and all the parts of speech that we have learned from class 2 or class 4 to class 8 when we were in school. Say, for example, big talk quickly. Again, spam detection. Yeah, we get a lot of mails around shit, like, buy this, buy that. And, some mails are important, like, let's go to Agra. Our friends do send it. And these kind of, spam detections are also possible with NLP. And it's a very, good use case of NLP. We are going to delve into it as well in the later segments of this webinar. So we have made good progress in the webinar too. But in the NLP side, in sentiment analysis also, we have made good progress. In co-reference resolution also, we have made a good progress. We have also made good progress in information extraction. But yes, I will show you some examples. So still very hard question and answers. We are still very hard at identifying the context. We are still very hard at, still struggling in paraphrasing as a use case of NLP, summarization as a use case, chat and dialogue is still, difficult, and we are making progress, but it's still under a lot of research. So if you guys can do it, that will be great. Now, with this challenges in NLP, I would like to stop and I would like to talk about some examples. Cool, guys. So let's delve into some examples. I will be using a Kaggle notebook to explain things to you. So here, for this Intellipaat workshop, I created uh this notebook, and here I'm going to talk about and present to you a real-time illustration of how we can represent text as numerical data. We are also going to read a text-based data set into pandas. We are going to vectorize our data set. We are also going to build and evaluate a model. We will compare models, and we will examine a model for further insight. And we will practice this workflow on another data set. Not needed. I won't go into these details. Let's see how much time I have. I need to cover it in the specified time. All right, so with this notebook, we would like to have a higher level view of the basics of NLP, which basically consists of combining machine learning techniques with text and using maths and statistics to get that text into a format that machines can learn from and understand. So before we start, let me import some libraries. So it is going to start the session. Just wait a second for the session to start. Meanwhile, I'm going to show you for some of the text how you can represent text as numerical data. So for converting text to numerical data, one of the very easy method is to use a count vectorizer. So count vectorizer is present in sklearn feature extraction.txt library. So here you can use count vectorizer to extract the count of the word in your sentence. And with this, when you will fit it, oh, okay, great. Session started. Did it run? Give me a second. Yeah, it ran. All right. So I have these three sentences: call you tonight, call me a cab, please call me, please. And let's see what I mean by count vectorizer. And it will become clear to you once I run this. So I ran the second line and I am invoking count vectorizer from sklearn and I'm fitting it to my library, to my list, which is the simple train list. So when I fit the count vectorizer to my list, so it is going to return that, hey, you know what? It's fitted. Encoding is UTF-8, then analyzer is word, n-gram range is 1, 1, and preprocessor is none. So you can play with all these parameters. I have not used any stop words here to the process that you have shown earlier? Yeah, exactly, Rajanpreet. I can. Just follow this and I will later connect it with the process as well. Like here, when I say get feature name, what I got all these tags. So they are just there because we have designed our language in such a way that we follow a sequence. We follow when we are writing a sentence, what does mean by stop word, right? When you type this sentence to me, by default in language, you want to follow a structure. You want to start every question by what. You want to, fill that question by does or did. You want to, then talk about what exactly is your question. So instead of does, if you will write something like this, right? I'm typing it to you. Stop words and question mark. I will still understand that, hey, you know what? You want me to tell you more about stop words. So these are stop words. What does mean by? Cool. So here, what I did, guys, follow me. I have a list, all right, of three sentences. In this list, I have three sentences. Call you tonight, call me a cab, please call me, please. Now here, I want to extract features. How will I get features? So what I will do is, I will convert each and every unique keyword that is present in this list and in the three sentence as one feature. And for that, I use something called count vectorizer. Count vectorizer basically vectorizes the sentence depending on the count. All right. Okay, fine. So here, text analytics is a major application field for machine learning. However, the raw data as a sequence of symbols cannot be fed directly to the algorithm because algorithms are equations. These are mathematical equations like uh, you know, add something to, a feature, which is a column, and evaluate it to predict which class it belongs to. These kind of equations are what we learned from the data and we call machine learning models. But in text, we don't have those calculations possible until we convert those words to some numbers. And these numbers are mostly context dependent. And one way of converting those text to numbers is using count vectorizer. All right. So using count vectorizer, we convert it to numerical feature vectors with a fixed size rather than raw text documents of variable length. Now let's see how exactly I'm doing it. So I extracted all the important keywords from this text, and when I print it, these are the keywords or these are the important words present in the text. Cab is important, call is important, me is important, and me is unique. Please, tonight, and you. So that's what we extracted. Only these words are present as unique words in this. Now, what I'm doing is I'm transforming my data set using the vector that I have trained on, and I'm returning it, right? I'm converting it to an array, making it as a data frame, and then I'm printing it to you. Now, see, this is my first sentence. In my first sentence, what all word is present? Call is present, tonight is present, you is present. Okay. Can you again go back and see the first sentence? Call you tonight is present. Call me a cab. Now, the way it is represented, cab is given one because cab is present. Call is given one because call is used one time and it is present in the sentence. Me is given one. Please was also used. So cab, call, me, please. These are the important words or the words which made this. Oh, wait, there is some issue. Oh. I have an issue with parsing. Please call me is also introduced. So these are the challenges, these are the challenges when I converted it, to an array. Yeah, right. So one hot encoding, you basically convert each and every feature, sorry, each and every label which is present in feature as a new column. But when you do vectorization, you do something similar to one hot encoding, but you parse the text into numeric vectors. So when I have it in form of arrays, it is a numeric vector. So I pass the text and I convert the text into number vector. So this is a vector. This together is a vector. So a vector has, but tonight is not present. Yeah, there is an issue with the way I'm making it a data frame. Ignore this line. This line is wrong. This line is wrong. Read the array that I have here. This line is basically to make you also learn that how exactly call me cab please tonight. So you can know that cab is a feature, call is a feature, me is a feature. Cab, call, me. So you read 111 is only present in the first three features. Cab, call, and me. Is that the only thing present? Call me a cab. A is not used because it's a stop word. Hence, a is removed. So those who wanted to know why exactly, so a is removed because a is a frequently used word, so it's not used in creating feature. So anytime in my feature list, a doesn't fare or a doesn't fare, correct? But tonight is present, and tonight is wait, tonight is not present in the first sentence. Call, me, and cab are present, and hence we have in array 1, 1, and 1 present for cab, call, and me. Similarly, we have information for call, we have information for me, we have please present two times. So this is how it gets represented. Call me, please, right? Please call me, please. For sentence, we can use vectorization, and for single labels or single words, we can use one hot encoding. For single word, you need not even use one hot encoding. You can directly use that single word as a feature. Wait, let me make it real. Okay. Alrighty. Where is Excel? Let's Excel in life. Okay. So you have a column, okay? And you have labels like yes, no, yes, no, yes, yes, yes. Okay. And you want to learn from it. All right. So what you do is you create two columns out of it. Say column underscore yes and column underscore no. And you fill where yes is present as 1 and where no is present as 0. Where no is present as 1, yes is present as 0. And when you have three labels, say for example, yes, no, and don't know, right? And when you do one hot encoding, there will be another column out of it called column underscore don't know. And you fill it as 0, 0, but 1 in this case, and 0, 0 to this case. So when you perform such step where you convert your categorical column to a feature space for each of the individual categories which is present in the column, then you do one hot encoding. So one-hot encoding is a pre-processing step of still a tabular data. So your data is still present in table and it has a schema, that is, it is present in column, and you only have three labels. But in text analytics or in vectorization, I don't have the fixed labels that please call me are the only features that needs to be created. Say for example, there is another keyword called Ankit. Call me a cab, Ankit. Please call me, please, Ankit. Maybe, my wife is typing, hey, you know what, please call me, please, Ankit. I don't know. She never types like that. But if something like this goes on, right? And I again implement account vectorizer and I will fit and I will get the features and the feature names. I will have Ankit also present. Ankit cab, call me, please, tonight, you. You see this? So Ankit, how did it learn? It learned the from the text and the richness of the text. So vectorization, there is no predefined schema, but in one hot encoding, you already have predefined schema. So how exactly we convert text to something which models learn from? All right. Now, from the scikit documentation in the scheme, features and samples are defined as follows. Each individual token. So this list, after I perform the count, this list is called list of tokens. So each and every keyword here are basically the tokens. That becomes the feature space. So let me again run this to you. Vector transform. Here you see, and this is just for showing it to you guys. Don't see it properly. This is the correct one, by the way, guys. So here Ankit was used. Was it used in the first sentence? No. So there is no one against Ankit, but one is used against Ankit. Again, if I use Ankit twice, say for example, Ankit, call me a cab, Ankit, and I run it again, and I fit it, I again fit, and I convert it. You see, Ankit is occurring twice in first sentence, so two is present. Correct? So this is how I can convert a sentence to feature space. Great. So the vector of all token frequencies for a given document is considered as a multivariate sample. So inside this count vectorizer, all these sentences are clubbed together and it becomes a text corpus. So club everything together. Forget that you have a comma here. Consider it's a complete single sentence. All right. Call you tonight. Ankit, call me a cab, Ankit. Please call me. All these together makes a text corpus. All right. This is a single text corpus. Exactly. Right. Basically extracting meaningful tokens from a sentence. Yes. Yes. So a text corpus is basically a block of text. It counts how many times a token is repeated within the sentence and not word. I am refraining from word because you remember a was also present, but it was not used because it was ignored as a stop word. So how many times the token which is identified is present? It will take into account if it repeats. Yes, it will take into account if it repeats, and hence it changes the count from 1 to 2 when Ankit was present in the sentence two times. And this is how information is present. So with this, so a corpus of document is represented in form of a matrix with one row for each document. So here, each and every sentence that you read is called a document. And this document together is called a corpus. So each and every document is evaluated and we are getting a feature space for every document. That a corpus of document is represented by a matrix with one row per document and one column per token. So each and every keyword here becomes one column and it is called token. We call vectorization the general process of turning a collection of text document into numerical feature vectors. This specific strategy, that is tokenization, counting, and normalization, is called the bag of words of or bag of n-gram representation, guys. Okay, so when anybody asks what is bag of words, so the process of vectorization of a document into the feature vectors or numerical feature vector is called bag of word technique. Great. Or bag of n-grams. So here, what is n-gram? I'm using n as 1. Documents are described by word occurrences while completely ignoring the relative position information of the word in the document. Very important point. Why vectorization? Because in vectors, right, we don't care about origin. We only care about, so any vector can have a moving origin, right? Origin is important, but a vector of 2i and say 3j can be moved in space. Those who have studied maths, we all have studied maths and we all have learned in vectors, right? That you can move a vector freely in the space. So that's what it is. So order in which the word occur in sentence is not important, but the count of how many times the word has occurred in the sentence is important, right? Okay, then let's check the type of this term matrix. It's a count. It's a CSR matrix. Okay. Then I'm printing it, so it looks like this. Okay. So it's a sparse matrix. Now, as most document will typically have very small subset of words used in the corpus, the resulting matrix will have many feature values that are zero. So essentially, when you do a text analytics or mining project, the matrix that you end up with are mostly sparse matrix because you end up with many tokens. And not all the tokens are present in every document. By document, I mean every sentence. Say, for example, Ankit is not present here. Similarly, there can be a some keyword which is not present. So we essentially end up with sparse matrix, all right, with many feature values that are zero, typically 99% of them. For instance, a collection of 10,000 short text document will use a vocabulary with a size in the order of 10,000 unique words in total, 100,000 unique words in total, while each document will use 100 or 1,000 unique words individually. In order to be able to store such matrix in memory, we also need to and also to speed up operation, we implement typically sparse representation that is used in scipy.sparse package. So it is also pretty commonly used. So here we are testing. Let's see. In order to make a prediction, the new observation must have the same feature as the training observation. So we have trained our corpus before for these vectors like call you tonight and on these tokens. Now I have a new string. Please don't call me. Let's see. Is my model or the corpus that I have trained, how does it convert this sentence to text vectors? So it shows 00111. So 00111. So what was 11? 00 Ankit and Gab is not present. Call me please is present, right? So call me please got learned and 111 is printed for this vector. But what happened to don't? Don't was not used, right? Why didn't use don't? Because it was never present in the corpus which I used for training. So the three sentences which I used for training, it never had don't. Hence, in the feature space, don't never fared or never came out. But let's try retraining my model of count vectorizer again with don't keyword 2. Let me again uh, type a sentence called don't call you tonight. Okay. If I use don't call you tonight, let's see how exactly my feature space changes. This time I learn again and I fit and I get feature space. Do I have don't? No, I have dawn, right? Again, it is ignoring and it is parsing. These are the challenges of these predefined libraries, like the count vectorizer. So it doesn't understand that, hey, you know what? It's don't. It's not dawn apostrophe T. Now, if I write don't like this, it will learn from it and don't will come as a keyword. This is what I was talking about in the beginning. And this is where the discretion of data scientists come into picture. When you are doing text analytics or you are doing such pre-processing, you need to be very careful like how exactly you want to process your text, right? So see, now don't will be processed, but I cannot process don't like this, but I need to process it like this. And let's again see my sample text. See, don't is used. You see the four keywords getting highlighted. What are these four keywords? Uh, don't refer it to it. Yeah, see, call, don't, me, please. All these four keywords got highlighted and got featured in my feature space. This is what. So once you have trained your model on the corpus, you can use it to convert any new document into the specified feature space, into its specified vector, into its necessary vector, not specified vector. Examine the vocabulary and the document of metrics together. Here. Please don't call me tonight. Great. Cool. Reading a text-based dataset into pandas. So here I have a library in Kaggle which I'm going to read. It's called spam library. All right. And let's read it properly. And here I'm printing the head of this data, which is provided by Kaggle, and it basically labels whether a given given mail is a spam or not a spam. and we are going to make or train a simple spam classifier. What we generally see in Gmail, right? Our emails are automatically categorized into spam mail, into primary mail, into important mail. All these categorization is performed by a model which Google has trained on millions of emails, and they have labels around it like, hey, you know what, this is generally a spam mail, this is generally a not spam mail. And those are basically rules, and I will explain the rules to you eventually down the line. And let's see, can we perform or can we do a good job in categorizing whether a message is a spam message or it's a important message. So I have basically two columns in my data set. The first column is label, and what all values are present in the first column. Let's again see SMS dot label dot unique to check what all unique values are present. Only two unique values are present: ham and spam. Ham basically means normal, spam basically means spam messages. So let me show you some general spam messages, okay? So SMS, and here I'm filtering for label is equal to spam. Cool, guys. Let's see. Double equal to spam. And this is how spam looks like. So I have 747 rows of spam emails. All right. And spam emails generally have words like free entry into a weekly competition, FA Cup final, winner, a valued network customer, had your mobile 11 month or more. Do they look like spam messages to you? This is the second time we have tried to contact you. Hey, this is not a spam. Or is it a spam? Okay, fine. What is the settings for printing the entire row in pandas? Print all rows and columns. Just give me a second, guys. I want to display pd.display, pd.display, pd.display entire column. Cool. Yeah. Okay. Perfect. This is what I want. Let's see. Will it allow me to read the entire text? It shows all the columns. No. No. Okay. Let it be, guys. So I need to individually see for label 2 what exactly. Oh, wait. In spam and in messages, message, and here I need to subset for 2. Pre-entry, right? Term and condition apply. Is it a typical spam? True, right? So this is what we are going to learn from. So in our data set, we have some spam messages. So what we are trying to do is we are going to learn from a data which basically has some spam messages and some non-spam messages or regular messages. And we are going to make a classifier out of it. All right. Cool. All right. So what is the overall size of our data set? SMS dot describe. Wait, let's do a shape. Cool. So our dataset size is 5,572 messages. In that, how many messages are spam? Dot shape. We have 747 messages as spam. The rest are not spams. All right. So what we are going to do is we are going to basically describe. So let's describe. So we have two different unique values in label, ham and spam. We have so many unique messages, but there are some typical messages like sorry, I will call later, which is very commonly seen in our data. Ham is most frequently seen in our data. It's the top record and it is present 4,825 times. Sorry, I will call later is another top record which is present 30 times. So that I do using describe method. Then I'm grouping by label to see how many times each message is present. So ham is present 4,825 times, spam is present 747 times. Yeah, cool, right? That's there. Let's convert ham and spam to vectors or two numbers like 0 and 1. All right. So ham is 0, spam is 1. We are interested in spam. So guys, from now onwards, we are going to predict 1. That means whether a message is spam or not. All right. So we will train our machine learning model on these 0 and 1 labels. Okay. So how I'm going to do it? And I'm also going to explain you the accuracy of the model. So as we continue our analysis, we want to start thinking about features we are going to be using. Now, what all features we will use? Do we have any features? We have only text blocks. All right. This goes along with the general idea of feature engineering. Guys, if you have done feature engineering, and if you have a little bit, if you apply a little bit of common sense, you can clearly understand that there is a pattern which spam messages follow, and we will leverage those. So those spam messages, right, will have certain keywords that will be very commonly seen, like free, like winner, like hooray, yippee, you won, something like this are very common. These keywords are what is going to differentiate a spam message from a non-spam message. Label number, do the variance, thanks. Suresh, I didn't understand what you were trying to imply, but yes, I'm analyzing the data using pandas. Okay, sorry guys. So for people who haven't worked in Python or don't know pandas, it will be a bit difficult to follow. Plus, but yeah, but please bear with me and understand the NLP concepts out of it, right? Like how I'm doing feature engineering, how I'm using, SMSs to basically classify whether a SMS is a spam or not a spam, and how I'm building a model. Just you are seeing a complete end-to-end data science project developed in front of you with me. All right. So just learn it. Don't look into the syntaxes like how I have applied what and all the things. Also, guys, be careful about understanding the data science aspects or data science concepts like feature engineering. It is a data science concept that I'm showing to you by creating the features. All right. So what features we will create, how we will classify. So you want to learn, right? You want to make your computer learn whether a given SMS is a spam or not spam. So how will you learn it? You will train a machine learning model on top of it. Machine learning model means a classification model to be more specific. So how we will train? A classification model learns from features, right? So how I will create feature? So from these text, I can create features like size of the text. So generally, the the spams, right? Their size may differ compared to the non-spam email. This is my assumption. So I'm creating a feature called message length, right? And here I'm using dot apply length function, and I created a new feature in my table called message length. So you see, this is a ham message or a normal message. Its length is 111. Another normal message length is 29. A spam message has length 155. Now I'm going to plot a distribution, and I'm going to evaluate my hypothesis that generally spams are shorter or longer compared to normal messages. So I'm going to make a plot, and when I made a plot here, I generally see that small general messages have word length very few. That means lower than 100 or 150. So this, my cursor is placed at 150, and most of the spam messages have text count of 150 plus. It generally goes above 150. So if I am very noob or very, very basic model, like a rule based model, what I will do, I will simply create a rule that if message length is more than 150, classify everything as spam and not of spam. So let's try that. Okay. Let's create a very basic model and say if message length is greater than 20, then make it spam, else not a spam, and see how much accuracy we achieve. All right. So SMS, and I will call it noob prediction. Okay. Noob prediction on length, and I will just say it as SMS. Sorry, I will use np dot where have I imported numpy. So again, guys, these are Python libraries. So those it might be bouncing from your head, but learn the concept which I'm explaining. The concept is how can we learn from feature? The feature which I created is message length, because I knew or I have a hypothesis that spam messages generally are lengthy compared to non-spam messages. All right. So np.where SMS, and what was my feature length? Message length. Where is message length? Here. np.message length greater than, let's use 130. Then I will flag it as spam. Else I won't flag it as spam. Okay. Predicted, let's call it predicted spam, and else predicted not spam. Okay, cool guys. Alrighty, so I created it, and this is my very noob model. And let's see how much accurate I am. Okay, so I am doing SMS dot group by, and I am then passing the columns. My actual column was what? What was the name of my actual column? Label. And what was the name of my predicted column? New prediction. So let's call these two label and new prediction on length. And I do an aggregate, and I'm writing count of records is equal to, what was the name of that column? Label, label, and I am going to do a count. So when I do this, you see, so how many of the spams I'm predicting correctly? Of all the spams, 747, with just a simple rule of length, I'm predicting 547 as spam correctly. You see this? What is my accuracy? My accuracy is 547 out of 547 plus what? 173. So by just creating one feature, I am having 75.9% accuracy in classifying spam and not spam by just using message length. But it has problems. The problem is I'm not predicting 173 SMS as spam, and I'm also predicting 669 normal messages as spam, which should not be the case. Am I correct, guys? Okay. So this is a confusion matrix in classification problem. And what I showed to you here is a confusion matrix. All right. So confusion matrix is used to evaluate. So instead of 120, let's make this, instead of 130, let's make it 150. No, 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 let's try to 150 because many SMS apps, right, have 140 as the length. Perfect. So let's try to make it 155 based on Mahin's suggestion. All right. So when I make it 155, what happens? I'm predicting as not spam 496. So I became poor. Why did I become poor? I became poor because 155 is somewhere here. So many of this area, right? The area below the big red uh, bar, I'm not classifying uh, as spam. So let's make it 140. Let's see my accuracy improves. Kya? So when I make it 140, I'm not predicting spam 262. So 130 was actually a good shot. Getting, guys, right? So greater than 130, and see, I'm predicting not spam at only 173 and spam as 545. Got it? So this is called precision recall optimization, or sensitivity specificity optimization. So this is again a machine learning concept, and you guys should know it if you have read classification. Wait. So I became better at, with 120, I became better at classifying spam. So my uh, accuracy got improved, right? But my misclassification for good SMS got worsened. It got worsened, right? So this is where you need to make a trade-off. So this is called sensitivity specificity trade-off, which is a very common trade-off in machine learning in classification problem. Balance it out. Yes. How do you balance it out? How do you balance it out? You balance it out by doing something called PR curve. All right. Read about it. It's a classification concept. When you will study classification, you guys will know about it. All right. So let's individually, exactly, PR curve. Perfect. Perfect. So let's individually understand these, hey, wait, I need to drop the columns which I created, no prediction and all this stuff. All right. So let me again delete these steps. I just wanted to explain to you guys. So let me again run a few lines so that I erase that. Else my entire flow will go bad. Perfect. So I created a feature called message length, and now I'm checking message length. So generally, my ham group has message length. Say, average message length is 71. 50% or medium message length is 52. 75th percentile has message length 92. But I do have some messages having length 910. Similarly, spam generally has messages of size 138. Right? That's the average length. So when I want to investigate for 910 character message, so I see this message sent by somebody to maybe his or her husband, wife, or girlfriend, boyfriend. So let's read the message. For me, the love should start with attraction. I should feel that I need her every time around me. She should be the first thing which comes in my thought. So this is another message, dude. And in text analytics, you need to parse all these information together to create your feature vector. So how do I learn from all such kind of information in a proper way to create a spam classifier? I just created a very basic feature called message length, and I was able to achieve an accuracy of 75% in front of you. So feature length is one feature for sure. Let's try to leverage additional NLP techniques and do pre-processing to create additional feature. Also, guys, I'm approaching time, so let's extend this session for 2 hours. If you are okay, those who want to drop, they can drop. Look at the recording later. But I think this is important, so let me cover it to you. Okay, I will be jumping, and let me know wherever you want me to stop. I'll be careful. So now what I'm going to do is I'm going to leverage. I'm going to clean all these messages, especially such ones, a very long one for stop words. Stop words are basically words that are not meaningful, and you can understand. You can understand. I will show you how it differs when I clean. So I created a standard function, and I'm using NLTK library. NLTK library is by default the best library for text pre-processing, and it has all the implementation for cleaning stop words, cleaning punctuations, and bag of words and other text analytics out of the box solution that we need. So I'm leveraging NLTK, and inside NLTK I'm using uh, you know I'm importing stop words class, and within stopwords class I'm using words method, and I'm passing a parameter called English because my text is mostly is English, and I'm cleaning for it. Now when I look at the head, so you see my text differ, so compared to what it was before. So this is my text, and now I'm cleaning it, and you will see how after cleaning for stop words my messages change. So this is my clean message: go until Jerjong point. But do we have until in this sentence? No, right? Why until? Because until was not important for the sentence or for the message to learn. That was not a significant keyword in the entire text. Hence, it got dropped. So I cleaned for stop words. Go Jerjong point crazy, available, bugs, and great. Crazy is important. Crazy is there, available. Only got removed because only was a stop word, right? Free entry into a week comply. A will get removed. I was telling you before also that a is a stop word. It is not significant. U is again not significant, so you got removed. Don't say so early, horrible. Somebody, type such messages, mostly a millennial. You don't say so early, horrible. Wait, I'm really interested in seeing this message, dude. So let's again, be a bit bad at reading people's message, and let's see what this message is. Okay, so message, and this is message number 3. So I'm checking what is message number 3. You don't say so early, or you see already then say. I don't know what is this. So somebody types something like this, right? But yeah, the point I wanted to make is this is what stop word removal means. I removed stop words, and I created a clean message column from the existing messages, and you see the difference. All the words that were not significant got dropped. Now, what is the type? It is a list, so it returns me a list. Then I'm going to create count, and I'm retaining the words having count. So for that, I'm using a counter, and for words in label ham, I'm counting what all words are present, and I'm taking the top 50 words having the highest count, and I will create a feature space out of it. So these are my top 50 words. In the normal messages, get is very common, LTGT, okay is very common, go is very common, ill is very common, no is very common, hey is very common, happy is very common. And let's check the count. In spam words, what is generally most common? Call is very common, free is very common. So most of the spam text, free is a very common keyword. Mobile is very common, txt is very common, text is very common, claim is very common, stop is very common, reply is very common, price is very common, guaranteed is a very commonly used keyword. See, dollar, sorry, euro 1000 is very commonly seen. 150 ppm is very commonly seen. So by just using a count, we can identify that we can make these as keywords, and we can use such vectors to classify messages as spam or not. So the count vectorizer that we talked about in the beginning, I'm going to implement on every message, right? So this is what I'm going to do. I am using a clean message. Then I created the label. Then I start applying the count vectorizer on test and train. So here is my vectorizer, and this becomes my training. So for training and testing, what I did, I split my data set into 70 to 30, and then I used a random state as one. So now I have two corpus 4179 messages passed for training, and 1393 messages will be used for testing. And I again created a count vectorizer as a feature. Then I'm going to transform, and I'm going to learn from the training data. Then I'm going to fit the vectorizer, and I'm going to examine the document or matrix. Then I'm transforming this to, I'm not sure if I can print it. Yep, cool. It got built. Now I'm going to use a term frequency transformer to count the frequency, and then I implement a very basic naive Bayes model, and I'm going to fit a naive basic Bayes model on my training data, and on my test data, I'm going to predict the classes. I have the predicted classes. Let's check the accuracy of the model on the predicted classes. I am able to achieve 98% accuracy, way higher than what it was before with the naive Bayes model after learning from the feature. This is my confusion matrix. In the confusion matrix on the test data, I'm only having misclassification. Wait, let me make all these things very real for you guys. So what I did here is I learned from all the text. I created test and train, and within test, I learned from all the information which is in training data, and I transformed the feature vectors, which is X-trained ATM. These are my trained feature vectors. Then, using those feature vectors, I transform the test data as well because I need to do the same prediction on the test set. Then I create a term frequency, TF-IDF based feature creator. So I transform the text using term frequency and inverse document frequency. Then on this, I built a model on all the features which was present in my training dataset. And I learned from the labels of the training dataset for the features that were present. Then I made prediction using the naive Bayes multinomial model. When I checked the accuracy came out to be 98%. Let's again see the prediction of these models. So y predicted class, and I will be applying it to y underscore test, x underscore train test. Where is x underscore test? It should be here. I am juggling between the notebook. I am trying to find the place where I did test entry. Yeah, here, x underscore test. So here I'm going to append the predicted column, and I'm going to show you how the predictions looks like. Predicted from NB model, and I will append the Y predicted class, which is my feature, and voila. See, now when you will see it, you can see the predictions. See, so these are your test, and these got predicted. These are your, wait, can I see the labels? Yeah, perfect. Why is it not coming? X test, is it a list? Just a second, guys. Oh yeah, it's a series. So I need to convert it to a data frame. X underscore test is equal to PD dot data frame, and then I will write the same thing. Then it will become a data frame. Do you mean pandas data frame? Yeah, perfect. Now if I add this column, oh, it is not. What is wrong? Okay, something is wrong, guys. I'm not able to convert this to a pandas data frame. The point being, I was able to get an accuracy of around 98% when I applied some NLP techniques. What were those NLP techniques? A very basic one. The count vectorization that I have used. after the length of text that I showed to you. And we were able to get an accuracy of 98% by implementing a ML model. Again, let's relate it back to what I was explaining in the PPT. The entire flow which I talked about. Remember, guys, I talked about an entire flow that there will be training label, there will be feature extractor, then there will be a ML algo and a classifying model, and finally we will get labels. This entire thing is what I would like to explain to you now. So, your training data was your text corpus. Did you see what happened? We got an accuracy of 98% when we used a count vectorizer. The same logic which I explained at the top, you know, uh, I used the same thing. I vectorized each and every text, and then on top of it, I trained after vectorizing, I trained a k nearest, I used a count vectorizer and I trained a k nearest, a naive-Bayes classifier, that too of multinomial naive-Bayes classifier. And using this, I was able to learn from the keywords along with the message length to together get an accuracy of 98% in classifying whether uh, spam message should be flagged as spam or not. This is what the whole demonstration was. And you can use such feature extractors for extracting features from your text data, and this becomes the first step or the first part in your my bad this becomes the first part of your first initial part of your text processing. And when you create feature, then you apply an ML algo. For me, it was multiple naive bias, and then I was able to predict the label. This was one demonstration of of machine learning and NLP, and with that we were able to get a good classifier that can classify whether a message should be spam or not a spam. This is what NLP is. This is what exactly NLP is. I showed you how stop words filtering works. I showed you how vectorization works. I showed you how a model is learned from the numeric representation of the text. That's it. Great. I also explained the challenges in NLP because there is ambiguity. Like don't and don apostrophe s was being confused, right? So how can we make our NLP models much better? So machine learning or deep learning are basically the types of learning. Multiple naive-Bayes classifier that I have trained is also a way to learn from the data. I can train another classification model too, like a decision tree, or say, for example, a random forest classifier, or an XGBoost classifier, or maybe I can train a support vector machine classifier. All these are ways of learning from the features that I have created. Similarly, another way of learning from the data is deep learning. So deep learning is a part of machine learning where we use algorithms that functions like how human brain functions. While in machine learning, we use algorithms that learns from from variety of possible ways of learning, like feature space segmentation in form of distance metrics, or in form of support vectors, or in form of just decision boundaries. Deep learning learns from how our brain functions. Our brain has got multiple neurons inside it, and each neurons are connected to another neurons, and an information is passed to the neuron adjacent to it in form of a product of stimulus versus the weight which the neuron holds. So depending on how your model is trained, each and every weight, basically a coefficient or a constant value, is assigned to every node before it passes the information to another network, another neuron in the network. And this is something like this. So right now, what I'm presenting to you is a deep learning network that has got 5 layers. So 2 layers are your input and output layer, and 3 are your hidden layers. So each and every layer has got a weight or a coefficient value which takes in each and every feature. So here we have features from x1 to xp. All these features can be your words when we are talking about NLP with deep learning. The the keywords or the tokens that I have extracted can be the features on which the deep learning model will be trained. And when I say training, I refer to the weights which this model or the neural network will learn before passing the information to another network, another neuron in the hidden layer. in the corresponding hidden layer, and finally returning me the output. In the output, I can see the final prediction, that is the label, whether it is a spam or not. So when I do machine learning using this framework that resembles human brain, I am doing deep learning, in which I have multiple layers of pre-processing and I extract progressively higher level features from the data. So there is a difference between deep learning and machine learning. What are these differences? Since I'm mimicking how human brain functions, I generally need very powerful compute. So it requires machines with GPU. I also need a big data set. Training time is also very long. Processing time is also very long. So in front of you, I made a machine learning name-based classifier that got trained within few seconds or hours. Training time was also very small. And we have many machine learning algorithms. Deep learning algorithms are very few. Also, interpreting deep learning models are very difficult. So right now, the name bias classifier that I implemented, I really want to explain and show it to you. But if I will go about writing the code for explaining, I will have to use multiple libraries like SHAP. So explainability is difficult in machine learning, but in deep learning, it is extremely complex. So but machine learning can perform well on small data set too. So these are some of the challenges that you need to decide before saying, hey, I will do this NLP project using machine learning or deep learning. So if explainability is a criteria that you have, that you want to have in your model, you should generally go for machine learning and you should generally go for simple classifiers like decision tree. Okay. Let's see another thing, another NLP use case. Here, I'm going to again show you a chatbot to you guys. Again, another illustration of machine learning and NLP. Wait, I need to log into my Google Colab account. Perfect. So here it depends on optimization. See, for example, in my project also, at the end, I have used multiple algorithms and I'm also going to perform algorithm selection. So that generally is a step. It's a trial, hit and trial method, which depends on many factors like, do you want to have explainability or how good is the performance of a model on your data. Say, for example, instead of say neighbors, I want to use multiple metrics. All right, let's say I want to experiment with other metrics. Okay, let's see. So what all, not metrics, but methods. So let's build this model in a pipeline. So what essentially you need to do is you need to apply multiple models and you need to learn from different models and you need to keep checking accuracy of it. Say, for example, let's try out logistic regression model. This is logistic regression model and I'm again predicting using regression model and I'm checking prediction probability and I'm checking accuracy score. My accuracy score for logistic regression model is still 98.4, right? Confusion metrics I'm seeing. I'm also plotting ROC AUC score. AUC score is 98.3. Instead of instead of logistic regression model, if I would have used a multinomial naive Bayes classifier, I was having an accuracy of what percentage? Where was that? I did print the accuracy here. Yeah, 98.2. So what worked better? Logistic regression gave me an accuracy of 0.03 times better or higher. This is what you need to do. You need to keep trying on the feature, on the dataset that you have created with features. You need to try out with multiple classification model and you need to see which model is learning the best. Yeah, we can try SVM as well. You can try XGBoost as well. You can try decision tree as well. And it's just a trial based approach. Some models have limitations. Say, for example, in XGBoost, you have a limitation that it cannot handle missing values, but your decision tree can handle missing values. So all these need to be accounted for. Again, neural network or deep learning based models, you have no explainability. But logistic regression gives you explainability. Decision tree gives you explainability. So it all depends on what essentially are you aiming for in your project. Do you want to explain your model to your business stakeholder, or it doesn't matter? Explainability doesn't matter. You just want to be more accurate. If you want to be more accurate, then use complicated deep learning model. You want explainability, then use simple models. And again, there are many other, rules around it. So here I'm demonstrating another project. Okay. It's called Chatbot. So I am going to show you how Chatbot is made. Again, I'm leveraging NLP here and I am reading a data. Oh, wait, I need to put in data. So where is my data? I will be uploading it. It will be on my desktop. It's a data.txt. This is my file. So I am implementing a text file in data.txt and I'm reading it and I am saving everything. It didn't get uploaded. Let me try it again. It should get uploaded. Yeah, here, data.txt. So let me read this file, and this is my raw doc. If you see this raw doc, this article is basically about what? This article, let me open that doc file to you too. It's about universes, all right? And I'm going to make a chatbot in front of you using NLP. So this is about universe. So you see things, you see what is multicellular, astronomers, important parameter determining future of observation, a map of supercluster is nearest to the Earth, dark energy, main article, dark energy, dark matter, all these things are written. All right. So in this data, with this data, I'm making a chatbot. So what I'm going to do is I'm reading this data, then I'm going to download two libraries, which is basically again for generating tokens. Then I am going to clean this data. I'm going to convert every sentence inside this to sentence tokens or to word tokens. All these are NLP terminologies. Then I'm going to do lemmatization and stemming as the text processing step, which I have showed you. Then I'm also going to write some simple greeting messages like hi or not hi. And I'm going to do a very basic TF-IDF vectorizer. And I'm going to use cosine similarity. So what is going to happen in my logic is every time user is going to type a sentence, a similarity measure is going to be implemented inside, and that will evaluate in the data.txt file which sentence is very similar to what user has typed, and that will be returned as a response. That's it. I am not going to do anything. I'm just going to run this, and here is my bot hosted and running for you. Hello, I'm retrieval learning bot. Start typing your text after greeting to talk to me. So let's greet him. Let's say hi. So bot replied hi. Let's again say hey. Let's see what it is saying. Bot is not saying anything. Oh yeah, bot is saying unable to understand you because I don't have any keyword for HEA, hey. You see, in my greet inputs, I'm only accepting hi, hello, what's up, how are you? So what I'm showing you right now is again a chatbot. Let me check with Intellipaat. I the point I'm showing all these things is to demonstrate, how exactly it works. So it's a chatbot. Yeah, it learned from my data.txt, right? So what exactly was inside data.txt? There were many things. There were things like second. All right. Let's see what is second. Does it reply back? Okay, it replied quarks, leptons, and the Big Bang. Second ed. This was the sentence which was the most commonly used, and it came first and it was returned. What is first? Okay. Timeline of the Big Bang was the most commonly used sentence. So you can see that it is not very intelligent, but it does understand what you are asking and returns you a text which matches very similar. So let's again read some sentence and let's ask him some questions. Okay, what are filaments? Are filaments. Okay, does it have anything to say? Okay, it is saying the formation of clusters and large scale filaments in the cold dark matter model with dark energy. So something it is saying, right? So universe and the dark energy. Okay, let's see. Does it understand this? Or it just returns me dark energy. So this is a demonstration of chatbot, how exactly chatbot functions. That's all, guys. This is the session. I demonstrated two use cases of NLP to you guys, and I also talked about NLP. I hope now you people understand how NLP functions and are also familiar with some of the keywords and terminologies in NLP, and you also know how to make a simple spam bot. Thanks, everyone. Bye.